Okay, so a gradient has developed. Okay, we're back at the beginning. We're 4.5 billion years ago, say. Not billion, just 4.5 billion. I stuttered. Just 4.5, 1 billion years ago. The planet is starting to come alive because of the tension between the energy from the sun and the planet's own reflection back into space. Because of the tremendous difference in temperature which emerges due to this interaction. And because of this tension, this pull towards the sun and towards the planet as gravity, we needed to be on a planet for there to be life. Um, this tension pulls these macromolecules together, in the shallow primordial seas, and they self-organize. They emerge into a higher state of complexity. And by complexity, I basically mean self-organization, but also a kind of circular causality, such that the parts, the macromolecules that compose this cell, are also catalyzing their own reactions to produce themselves and the boundary that they define themselves with. So it's a completely autonomous entity. Not autonomous in the sense that it can exist without the matter it is made of, the planet it is on, and the sun that is shining on it. But autonomous in the sense that it cannot be predicted. It can only be interacted with and participated in as your conscious state, which has also emerged out of this tension, is not other than your interaction with the world. So we experience a reality, and it experiences us. We are matter, but we are also the experience of matter. Just like matter itself doesn't exist without light, it can't be seen. No, literally, when the lights are out, there's nothing there. If it was all empty space, if hydrogen was the only element which ever formed, then yeah, maybe stars would have lit up, but there would have been nothing for their light to come into contact with, and so nothing to see the star. So our human linguistic abilities and conscious attention and technological skill, all of that is very real and very powerful, but it's also emerged out of all of this other stuff that's going on. And it's physical stuff, yeah, but it's also energetic stuff. It's light. It's time. What is that? And any discussion about entropy, you always have to get into time, because thermodynamics and the invention of these laws of thermodynamics was required because of the nature of time, because one could not predict the future with certainty, but only with statistics, with probability. Because when you try to understand a system composed of many components, it's impossible to keep track of them. Not because you don't have the technology to measure it, but because measuring it would alter it. For example, to understand the way a living organism metabolizes. I mean, you can do it, but to do so, you have to perform some rather invasive procedure. Um, and we're getting better at not having to do that. And as we do, we're learning more about how, I don't want to say miraculous, because I think we can understand what's going on, but how autonomous the body's operations are. They're not caused by what we normally think of as material efficient causation. They have more than that. I mean, they must not disobey the laws of efficient material causation, but they have the ability to act in the world beyond just being the domino being knocked over by its past. I mean, we can alter the future by making a choice, and we don't always make the right choice. Some choices are better than others, though, and some people seem especially adept at making good choices most of the time. So, to say that we were just physical machines caused by the determinate, permutations of the information of the past, why? I mean, then you're giving responsibility for your existence away. You're completely nullifying yourself. What about the rest of human life, like art and ethics and human relationships? And I mean, how do you deal with that after you've said that you're a machine? Because it takes I can't even argue with that as a hypothesis, because it takes a certain understanding of what science is, what the scope of it is, for you to even hold such a view. And so, rather than argue against that particular hypothesis, I would argue against the way you're understanding science's role in the human experience. It's supposed to be empirical, right? Empirical. And to do that, it's supposed to remain within experience. It's not supposed to contradict the reality we know with our senses or with our reason. I mean, if our science is completely irrational, we probably have a problem too. And if it's irrational and empirical, we might have a problem with the definition of empiricism. And that's pretty much what's going on in quantum physics, right? Because, it's all based on technological experimentation, building machines that actually perform these functions. 17-mile-long particle colliders. So that's supposed to be the empirical part, and the part that we learn mathematically, that we derive from these experiments, is, as mathematics, it's perfectly coherent, but as soon as you try to put it into English, it becomes nobody knows. Becomes a complete contradiction. Yeah, a photon, it's a particle, it's a quantum, but it's also a wave. Sorry, it's just what it is, isn't. What is that? I don't know what that means. Nobody knows what it means. The equations work, and they help predict things to a very high degree of accuracy, so there's something that it is like to be a photon. We can say that with certainty. Something it is like to be an electron, something it is like to be an atom. What exactly that is seems unclear, at least based on our current understanding of empiricism, which is building these huge machines to trap matter into a particular type of behavior. I'm going to have to make a part 3, I think.